Gotta love that countdown music, right? Good morning, good afternoon, good evening to you, wherever you are joining this live stream from, or wherever or whatever time you're watching this replay. Thank you for joining me here. I'm your host, Michael Jenkins, and this is session five, actually, is session six of CICD Summer School. It's labeled as five because we started counting from zero. So happy to have you with me today. And as always, let's be interactive. Uh, this is a discussion, right? It's a two-way channel for us to chop it up on the topic that we're going to be discussing today. So if you have thoughts, comments, questions, whatever the case is, drop them in the comments wherever you're watching this on LinkedIn or YouTube. Even on the replay, drop it in the chat for the replay, and if I can get back to it, we'll talk about it. We'll chop it up. But if you're watching now live, we'll definitely get to it. So this week for our interactive portion, I'm joining from Southern California. I always wonder where people are watching the live stream from. So if you want to shout out your hometown or wherever you're located now, or whatever the case is, let me know where you're joining from, and we'll shout out your people. Like I said, I'm joining from Southern California. The weather has been great these past couple of days. I've been really enjoying my patio, getting out there to get some sun. Just, because working from home, I'm not in the office, I'm not getting out or whatever. So I want to get out even while I'm at home. So that's been fun and enjoyable. Let's see, we've got Frosty Lindbergh in the building, joining us from Minneapolis, Minnesota. Thanks again for joining us, Frosty. Glad to have you here. Happy Friday to you as well. And let's see, the other question that I like to ask is, what are you working on? What's been keeping you busy for the past week since the last time that we connected? For me, I've been working on my Python scripting for one. I do a lot of data analysis at work, and I like to use Python for that. So I've been scripting, just here and there, making some projects to get things simplified for me. So, pulling the data, formatting the data, basically good ETL operation, right? Extract, transform, and load. I'm extracting the data from one place, transforming it into the actual format that I need it to be in, which is a little bit different than the source, and then loading it somewhere where it can be useful for people. So that's what I've been working on this past week. Let's see. And skills that I've been working on, outside of my Python scripting, which is not so bad. Python scripting is not so bad. The other thing that I've been working on is static website development. So I started using WordPress years and years and years ago, and I've got some old kind of crusty sites that are still running WordPress. I want to get them off of WordPress, which is still a great platform, by the way, if you're using it. No shade to WordPress. But I want to try out the whole static website thing. So I've got some websites that I'm working on or moving from WordPress to Jekyll. So probably GitHub pages, maybe Netlify, one of those services to get those assets served up. And then once everything's online, I'll modify my DNS to point from wherever they're hosted now to wherever they will be hosted. And, we'll have something going. There will be a lot of CI/CD involved in that because I'll be running the Jekyll process in my GitHub Actions workflow to get those pages and those static assets published. But you don't want to hear about all that. Let's jump into the first segment that we usually get into here in CICD Summer School, which is Around the Way. Around the Way is a segment of the show where I share content creators that I follow, podcasts that I listen to, and resources that I use to hone my skills. I find them useful, and I hope that you will too. So let's get right into it. Google Alerts is the main thing that I want to share with you today, and kind of give you some insight in the way that I use it. Google Alerts is a product that's been around for quite some time, and basically, what Google allows you to do is specify a keyword, and as they index content across the internet around the world, they will share that information with you based on your keyword. So this is great for us as automators and as technologists, because as we depend on different technologies, we need to basically stay up to date. And using Google Alerts is an excellent way to do that. So what I have displayed here right now is one of the ways that I use Google Alerts to stay up to date with GitHub Actions. I've got a few courses on GitHub Actions in the LinkedIn Learning library, and I just like to stay up to date on it because I also use it for my personal use. I use it at work, and I want to know what changes or what's going on with GitHub Actions. So I have an alert for GitHub Actions. So just following these numbers, 1, 2, 3 through 5. I specify the subject, which is GitHub Actions. And then as soon as you put in the subject, you're going to start to get a preview of what the alert will look like. And so in this example, you see a few options that kind of pop up. But then if you click that show options button, now you could just stop right there. You could just go to Google Alerts page and put in your topic, and it's almost like doing a web search, right? But the benefit here is that if you go to number 2, show options, you can sort of configure the way that you can get these alerts, right? So number 3, the third step in this process is to tell Google Alerts how often you want to get updated, right? You can just say, notify me once a day, once a week, something like that. I like the as it happens option, right? So this is like how you can stay on top of cutting edge news happening, whatever the case is. As Google is indexing these articles after they're published, you're going to get them sent to your inbox, and we'll get to that in a minute. I like the as it happens option because I want to stay up to date. And usually it could be within maybe a few hours after something is published, maybe a day, depending on what their indexing is looking like. But I like to stay up to date as it happens. So then going to number 4, you can also select the source of the information. If you only want to get stuff from blogs, videos, whatever the case is, then you can select that as the source. And maybe that's key to your subject. But if you select automatic, then Google will use whatever algorithmic magic they have behind the scenes to pick those sources for you. So I just click automatic and say, let the robots figure it out, right? And then step 5, enter your email, you save this alert, and you start to get your alerts from Google. Kind of like this one right here that I have displayed. So this is an email that came as a result of my GitHub Actions Google alert. And I mean, very relevant to the topic that we're going to discuss today. The first item in this particular alert came on August 19th, 2024. GitHub Actions artifacts leak tokens, expose cloud service and repositories. And you see this headline, and you're like, oh my goodness, what's going on? We'll talk about this a little bit more. But I just wanted to show you this example of how you can use Google Alerts to stay on top of whatever subject you might want to choose. But like I said, us as being the automators, the CIC practitioners, and the technologists that we are, this is a very useful tool for us to stay on top of the frameworks and tools and services that we depend on so that we can get that information as it happens. Okay. Moving on to the next segment here. Last week was a great session. We talked about canary deployments, which was actually an overflow from the session before that. And we just took a closer look at how canary deployments takes a little bit of the best of everything from rolling deployments, from blue-green deployments, and gives you a safer way to roll out changes to your environment. We talked about the background of canary deployments, how miners use canaries to protect themselves in mines and dangerous situations there, and how software development has adopted that progress or that process in our pipelines and deploying our applications. So I really enjoyed that discussion. If you weren't present or you missed it, go back and check out the replay of session 4. Canary deployments. There was some homework that was involved with that particular session. There was an article Canary released by Danilo Santos at ThoughtWorks, kind of gave a little bit of the background of Canary deployments there, another reference for you. And then also some labs. There was the Cloud Run Canary lab that was for Google Cloud Platform. And then there were a couple labs from AWS, and it was on Blue Green. So that was like kind of an overflow from the session before where we talked about multiple deployment methods, including the blue-green deployment approach. So just, some resources for you to either just like read through those labs to see like the steps that kind of are involved with setting up a blue-green or a Canary deployment, or actually implement them yourself so you can actually put some rubber to the road, iron sharpens iron, steel sharpens steel type of thing to hone your skills in using these deployment method approaches. Okay, let's go into the meat of this session, session 5, which is the 6th session of CI/CD Summer School, securing delivery and deployment pipelines. Oh man, security is it's I don't know. I try to be safe online. you know, I don't claim to be a security expert by any means, but some of this stuff to me is just fascinating. The attack vectors and the ways that we can protect ourselves from these attack vectors. Um, yeah, let's just get into it. Let's just get into it. Um, and what I wanted to start with as we discuss this topic is the concept of shifting left. Now, you might hear people when they're talking about, online security or whatever the case is, software development, they'll say, we need to shift left. We need to shift left. What does shift left mean, specifically when we're talking about security in the software development lifecycle, or the SDLC? And I've got that spelled out here on the slide. So first of all, let's talk about the SDLC as it is. And typically, the software development lifecycle is a pipeline or a process that is read from left to right. Starts with the develop stage, where we're actually coding and developing our software. And it's followed by the build stage, where we take our code and we actually build it into an artifact. And then we have the deploy stage, where we deploy that artifact into the environment where it's actually going to be running, or where we make an artifact available for download for people to use on their systems, their phones, whatever the case is. And then we have the operate stage. Now, and I should just to clarify, the operate is where if we're running a service or we're running a system, the artifact's been deployed into that compute, or whatever the case is, wherever it's running, and we're actually managing this artifact on a day-to-day basis, right? And this is kind of a simplified software development lifecycle. There may be some other stages before or after these, or whatever the case is, but I just wanted to kind of summarize that entire process in these 4 stages for the sake of this discussion. So in the operate stage, that's the first time that we start thinking about security in a lot of cases, right? We think like, hey, we've got this thing, we've built this artifact, we built this piece of software that we want to share with people, and we've deployed it. It's a website, it's a service, it's a mobile app or something like that. And now we got to be secure, right? We got to protect the thing. So we start thinking about security, and how we can protect our application while it's running, while people are using it, and so on and so forth. However, bad actors are getting ahead of us by taking a look at earlier stages in the pipeline. They're looking at ways that we're making mistakes while we're even developing the code. They're looking at the ways that we're building our artifacts, and they're looking for holes that they can poke there, or crevices that they can creep into and steal things or break things, whatever the case is. They're also looking at the ways that we deploy this software, or the artifacts, whatever it is, and how they can make use of exploits in that particular stage as well. So we're out here on the far right-hand side, being super secure, operating this software. Meanwhile, The bad guys are busy way back before us, already causing trouble, right? And that's the problem that we're trying to address when we say we need to shift left. So particularly, let's get rid of those bad guys. I'm going the wrong way in my slides here. What we need to do is take our security mindset and go back the other way. Instead of moving to the right, develop, build, deploy, operate, we need to go back to the left and start thinking about or being more aware of the security needs further, back earlier in our software development lifecycle, earlier in our pipeline. So we need to be thinking about security while we're building and deploying. And even before that, we need to be thinking about security while we're actually even developing the software, while we're writing our code. We need to have security top of mind. So that's just kind of an overview of the concept of shifting left in the software development lifecycle. Let's see like some of the ways that we can apply a security mindset in some of these stages. So in the develop stage, the first thing that we got to do is like secure our repositories, right? We can't just let anybody be writing code or contributing code to our repository, right? And a lot of the repositories that we use, GitHub, Bitbucket, GitLab, and so on, they're good with this, right? Because even if you have a public repository, you still have to have permission to write to the repository. So that's pretty good, right? But we also need to take that a step further and add MFA or multi-factor authentication to our accounts. Because if we have, username and password and that gets compromised, then any bad actor that has that information can log in as us, and then they can start contributing code, messing with stuff, and even as ourselves. So that's even more difficult to determine if there's been an attack or something like that. So we need to add another layer of hardening to our accounts, and MFAs is one of the ways that we can do that. Security keys is another way that you can do that as well. Also, thinking about the first stage in a CI/CD pipeline, the integration step usually happens as people are contributing code to a repository. At that stage, that's a good time to get our security, monitoring and observability in place. And we can use tools like static analysis tools that scan for potential problems in our code, or they scan for other known vulnerabilities. Maybe it's a CVE or common vulnerabilities and exposures that we're not aware of, and we can generate a report for those depending on the framework or the programming language that we're using. We can also scan for credentials, because the last thing you want to do is have credentials in a public repository. More than likely, probably 99.9% certainty, if you have credentials in your repository, they're going to be abused in some fashion. Don't let it be a cloud credential or something like that, because that's definitely going to get taken advantage of. So early on in the development cycle, we can scan for these type of things so that we don't have problems down the road. Okay, in the build section, that's where we're actually taking the code. Hopefully this code is good. It's intentional. It's what we want the application to do, and there's nothing funky or vulnerable in the code itself. We build that code into an artifact, right? As we already mentioned in the develop step, we want to keep credentials out of our artifacts, and we'll definitely talk about that here in a minute. We also now have the capabilities to sign and validate our artifacts. The one link that I'm sharing here is GitHub Artifact Attestation. So that gives us the capability to say, hey, yes, this is an artifact that I built. This is the hash for it. And this is, it's solid. It's good. No changes have been made to it. This is what we expect it to be. And yea, verily, it is. And if we provide that information, then our end users or anybody who's consuming the artifact, they can validate against our attestation to make sure that they actually have the correct artifact. So that's just another way that we can kind of keep our build process clean. And then we can also use the concept of a software bill of materials, also known as an SBOM. A bill of materials is basically a list of all the dependencies for the artifact, right? So if you can imagine, and I'm going to mention Node.js, npm, and all that kind of stuff. When you do like an npm install, and like you see all these libraries start to get installed, and you like, what the heck is going on here? How do you keep track of that? There are tools that can say, these are the libraries that you have included in your application. These are the versions. And maybe if you take it even one step further, you could say, these are the libraries that those libraries depend on. So you have this whole graph or this whole tree of everything that's been bundled up into your artifact. The reason that that's useful is you can use that information to determine if any of those libraries have vulnerabilities. So even if you're scanning your code for vulnerabilities, you don't know if somebody down, or I guess upstream in this case, where you're pulling in their library, if they have vulnerabilities in their code. So the SBOM can help you with that. It can also help anybody that's using your code themselves. If they want to see like, hey, what's actually in this package, then they can look at your SBOM and kind of figure things out that way. Um, Finally, talking about build, in the SDLC, the build stage, we want to use short-lived build environments. And by this, I mean, we don't want to have a server, if we can avoid it, a server that we use over and over and over again without sort of refreshing that server. Because what will happen is we'll have, you know, kind of this cruft, like stuff that just gets left around. And if we don't update and patch the server, then we're more susceptible to vulnerabilities. And then attackers can take advantage of that. If they can get an account on this build server, and you're pulling in credentials into a build process, and they get access to those credentials, then they have an opportunity to exploit your build server. The way that we can work around this is by using short-lived or ephemeral build environments. So GitHub Actions, Bitbucket Pipelines, two good examples, and GitLab CI as well. Two good examples of build frameworks that allow you to basically run your build job in a container or a VM that you run your pipeline on, and as soon as that pipeline is done, it's gone. Don't even have to worry about it anymore. And that's particularly important for public repositories because, again, if somebody becomes a member of your team in a very sort of surreptitious way, and they have some bad intentions, and they have access to your build servers, then they can get access to credentials and other things that you may not want them to have access to. So definitely use short-lived build environments as well. Okay, now let's take a look at the deploy stage. And again, we've mentioned credentials on just about every stage, right? But we want to also, in this stage, particularly protect and limit access to credentials. It's important in the deploy stage because the credentials here are more than likely the keys that allow us to put an artifact somewhere, right? That could be in a container registry. It could be in some other artifact registry. It could be the permissions to access a compute resource in a cloud vendor. And if an attacker or a bad actor gets those credentials, then a lot of times they might have the keys to the kingdom if we configure those credentials incorrectly. For the repository storage, or rather the artifact storage and container storage, that's also bad if we lose access or get credentials stolen for those particular places, because then bad actors can put their own artifacts where we're storing our artifacts. So just imagine somebody, you say, hey, take my application version 1, it's great. Bad actor gets your credentials. They say, you know what, I'm going to deploy my version 1, version 1-bad, where your version 1 is sitting, and then our friends download the bad version 1, and now everybody's been hacked. It's not a good look that way. So to prevent this, keep the credentials out. And even when we create these credentials, we need to give them the least privileges possible. So if you create a credential to put a container image into a container registry, for example, That's all that that thing should do. You shouldn't have any other permissions outside of that. And we're guilty, a lot of us, perhaps me included, as a CI/CD practitioners, because we'll say, you know what, I need to deploy this thing. I'm just going to create a service account that has admin permissions because it needs to do everything. And I'm guilty for this when I started learning to cloud and do all this other kind of stuff, because you'll run into a problem, right? Maybe you start with a security mindset and you'll say, hey, I just need to deploy this image into ECR. And then so you pick maybe one permission, maybe the permission that you think that you need, and you try the deployment and it fails. You're like, okay, well, maybe I need this other thing. So you add that and that fails. And you're like, you know what? Forget it. I'm just going to make this service account an admin for my entire AWS account. That way I know I won't be blocked by any other permission issues. And this one little container that I'm building over here for this little Hello World project will be able to be deployed. Meanwhile, you expose those credentials, somebody gets them, and then they have the keys to the kingdom, right, for your AWS account. So we're keeping our credentials out. Where the credentials that we use, we're trying to make them as localized, as minimized as possible. And then we also have the capability to use short-lived credentials. And we can do that with the OpenID Connect, also known as OIDC. And in this process, we set up roles that have permission to request credentials. Instead of having like a hard-coded access key and secret key, like for AWS, and putting those in our repository secrets, which I am guilty of. I am completely guilty of that. I do that all the time, right? But a better approach is to use these roles that have permission to request short-lived credentials. They use the credentials, they do what they need to do, and then those credentials expire within a matter of minutes. So that way, if somebody does get those credentials, if they are exposed, then the time that they have access to them is at least limited, right? You can also set up additional permissions with OIDC as far as like, you can only use these permissions from a specific location or from a specific IP address. There's other ways that you can add layers of hardening to the ways that these tokens are used. But whatever the case is, the goal is to limit access to the credentials as much as possible. Speaking of limiting, we're also going to limit deployment targets to a single environment. Well, what do I mean by that? So we may often have code that we want to deploy to a test environment, developing, staging, and production, right? We want to test things out. So the credentials that allow us to deploy to the test environment should only allow us to deploy to the test environment. We shouldn't be able to deploy, with the particular test environment role into production. Because again, we're just trying to limit the scope of things, right? If somebody gets access to credentials, these admin credentials in our test environment, and then deploys them or use them to deploy to production, then we're kind of messed up, right? We've circumvented all this other security that we've tried to have in place. So we want to limit the permission for deployment into a particular environment to only that environment. And we did have a comment from Frosty. I'll pull up. It's kind of long. I don't know if everything can show on the screen, but it's been interesting to see the evolution of cybersecurity and the reality that things can and will be breached. Yes, they will. Yes, indeed. And the mentality and preparation needs to be one of both minimizing the opportunity for exploits and having a clear mitigation steps and timelines for the inevitable. It's gonna happen, right? I mean, unfortunately, yeah, it's going to happen. So you got to be ready for it. Yeah, never leave secrets or credentials in plain text anywhere. Just don't do it. Just don't even do it. And we're all guilty though. Particularly if we're new to the game and we're learning how to use these tools, we make mistakes, right? But the sooner that we can adopt these practices, then the better we'll be down the road. Okay, what's next? We got some case studies here, and I mentioned that we're going to talk about some of these things. Let's get into it. I wanted to share my screen so that we can take a quick look at some of these. Um, Palo Alto Networks do an amazing job. The team that they got there, they're doing the thing, right? They do an amazing job of analyzing uh, uh, attacks or breaches, and then presenting that in a way that we as practitioners can learn from, the event and apply changes to our environments. Particularly, I mean, they're selling a product, right? They want you to use their product, so they'll demonstrate how their products can protect you from that. But I still appreciate the sort of neutral stance that they take to say, like, hey, this is what happened, and this is how you can prevent it, right? So this one popped up not too long ago, of how there you can exploit a race condition in GitHub Actions artifacts. And basically, what happens as you upload an artifact, if your artifact contains credentials, particularly in a public repository, people can take advantage of them. And I have this section highlighted here. I'm just going to go through the executive summary at the top. That we all know that CI/CD environments are essential. Building, testing, delivering code to production. So they contain the credentials that we need to do all of these things, right? And we have to practice a high level of credential hygienes. So, and in this article, they show that even if you're doing some of that stuff, but you make one tiny mistake, that somebody can take advantage of your pipeline. And really, I read these things like a novel. They are fascinating to me because I love the technology behind it. And the story of how they figured out what's going on is really it's riveting. So I encourage you to take a look at that. In this particular one, I wanted to see if this is the one. Yes. What I appreciate about this particular one, they actually have screenshots of how they are exercising the attack vector. So let's just take a quick, this one's only 43 seconds long. But in this case, they are taking advantage of this particular repository by injecting their own artifact into somebody's repository, right? The vulnerability here is this superlinter log action actually leaks credentials that they can take advantage of and use them to write back to the repository their own artifact, right? So, and that's what they're demonstrating here. They've swapped out the artifact for this particular run with their own artifact, and they even show the inside of this particular artifact, which is crazy to me. And that's what you get. You think you're going to get something beneficial, and then you end up with this reaper, right? So take a look at this particular article. Like I said, this one is fascinating. And let's go to the next one. Okay, this one is for actually affects services or applications, or actually more like code, I guess, storage in AWS. And it could affect other bucket vendors, because I mean, if you're basically, buckets are like almost, particularly if you configure them as a web page, right? They're just serving up the contents, whatever's inside them, they're just serving it up, right? So what people are doing, what attackers or bad actors are doing, is they are looking for buckets that have a .env file inside them. Now, as a developer, we're using .env files, which should be hidden, right? It really should be hidden from everything to store our credentials. When our application boots up, then that .env file contains, some environment variable settings. Our application pulls those credentials, or that pulls that information in, and then it operates as it normally would. In some cases, we as developers are including the .env and maybe even the .github or other hidden files in the artifact that we're making available for public download, or we're actually even deploying it to a web service where anybody can get to it, right? So that's also kind of crazy. This was another good article that I found very fascinating and just very interesting, because I'm like, okay, do I have some buckets out here that have .env files in them? So definitely read through this one and take a look at it as well. Okay. Let's go back to the slides here. Um, and I think that brings us to, yes, it does, to the homework for this particular lesson. I want you to create some Google alerts, right? If you use, I don't know, Team City, maybe make a Team City Google alert. If you're on Jenkins, Jenkins is kind of tough, right? Because it kind of matches a lot of different things, but maybe you can dial in some extra keywords into your alert subject to get the information that you want. And again, you could see sort of the samples that pop up so you can dial it in as precisely as you need to. So go out there, create some Google alerts. And then I want you to take a look through those Palo Alto Networks case studies. Again, they're short. I think the first one might be about a 15-minute read. The other one was like about a 10-minute read. But I just raced through those things because they're riveting to see the steps that they took to either recreate the attacks or to describe the way that the attackers are actually exploiting the pipelines or the services. So I think it'll be an enjoyable read for you. As you're doing all of that, think about your CI/CD pipelines. I know as I was preparing for this particular lesson, I thought about all the pipelines that I've got out there and like, are my pipelines at risk? I just kind of pause and think about it. Like, what do I need to change? I think I'm pretty good with artifacts, but who knows? Have I done something that I didn't expect? Have I created a deployment role that has more permission than it should? And maybe I can review that. So I just want you to think about your CI/CD pipelines and how they might be at risk. The other thing that I'm thinking about as I consider the security, and like I said, I'm guilty of it in my courses. When I tell people to set up an AWS account and we're going to be deploying things from Jenkins, Bitbucket, AWS, whatever the case is, I'm telling them, hey, get these access keys, put them in your secrets, which is a totally acceptable process, right? It's totally acceptable to do that. But a safer way is to use OpenID Connect, right? So I'm taking the onus. I'm putting this task upon myself as I develop courses in the future to instruct people to use OpenID Connect, because honestly, that's the way that we really should be doing things to keep things as safe as possible. So that's homework for me, right? You don't have to do that, but that's definitely homework for me to look into OpenID Connect and start using that in my courses. So that brings us to the end of the slides. Let me go over here to my notes to see if there's anything that I need to mention for sure. Let's get rid of these slides here and go to the banners, because next week, I know we talked about how many sessions is it going to be in the CI/CD summer school? And I was like, it's going to be this many or that many. I don't know what the case is. Well, the summer is coming to an end. As much as we might hate to see it, time waits for no man, right? And so we're moving into the fall season. I mean, we still got some time left in August. It's not quite Labor Day yet, which is kind of the unofficial marking of the end of summer. But yeah, we're going to have one more session. And in that session, we're going to have a final exam. So we're going to go back through all the sessions that we discussed throughout the summer. And I'm going to ask some questions. Maybe we'll have some discussion right here live and online or in the replay. I'll pause for a second, give you the opportunity to think about the question and provide your answer. Then we'll see the correct answer and we'll have some discussion around that. And that'll be the final exam. Once we wrap that up, you will be a graduate of CI/CD Summer School, and you'll be able to take that knowledge and apply it to your own personal projects, take it to work, tell your friends, tell them to come back and watch the replay on LinkedIn Learning or YouTube, wherever it's most convenient for them, so they too can level up with the stellar knowledge that you now possess. So that'll be next week. As soon as you see that announcement come out, again, maybe it'll be later today, maybe it'll be this weekend, but sign up for next week's session and then start studying. Take a look back at some of the topics. Oh, and that's the thing. The one thing I didn't share before I get out of here, I got one more thing to share. Um, I forgot to share the repository. So if you've been following along, you'll see on the homework screen how there's a QR code and a link to get to resources for this particular session or for previous sessions. And in this sessions, I've got links to those articles from Palo Alto Networks, and I've got some additional resources that you can use to get more information on the topics that we discussed today. For example, shifting left, GitHub's artifact attestations, using OIDC in GitHub Actions and Bitbucket pipelines. I'm going to be reading those articles from top to bottom. Okay, easy. And then there's also an article on software bill of materials. So definitely scan that QR code, follow that link, and get to this repository so you don't have to like Google search for these articles that I've mentioned. And you also have some additional references that you can tap into as you consider the topic of CI/CD pipeline security. And then you'll be all set for the fall exam next week. That's it. Done deal. So thanks again for joining me again on the live stream, for joining me in the replay on YouTube and LinkedIn. I really, really do appreciate your time and attention. And I hope that this information that I deliver is beneficial to you. I'm looking forward to seeing you again next week for the final exam, the last session of CI/CD Summer School 2024. Y'all have an excellent weekend, and I'll see you soon.